We are to our last example, and this example is really important because when you first look at it, you're kind of thinking to yourself, what can I do? Maybe let me rewrite it. Okay, so let's see, if we try to rewrite it, then we would have the integral dx over, and then we would have the square root of x squared minus 4x cubed, right? Here's the issue. The issue is what's inside this radical, because everything that we've worked with so far, and when we're talking about trig substitution, we're assuming that we've got expressions of this format: u squared plus or minus a squared plus or minus u squared, right? So we know how to work with those. There's no form for u squared plus or minus a u, right? That is not, that's not part of the format, right? Because these special forms are related to the triangle, right? And there's nothing in the triangle that involves u squared plus au. Or is there? Dun dun dun. Here's what you have to do. Complete the square.
It's 19 hours.
Completing the square. So here's what we'll do. We'll complete the square, do a U-substitution, and that will turn the denominator into something with an expression of this form that we're used to. So let's get to work. So we've got the square root of x squared minus 4x. So let's see here. So x squared minus 4x, we're completing the square. It's going to be the same thing as x squared minus 4x plus 4 minus 4, right? So remember, you take this coefficient here, divide it by 2, and square it. And that's how you figure out what needs to go here. And then, since we added 4, we have to subtract 4 to keep everything, the expressions stable. So now, we can rewrite this as x minus 2 squared minus 4. So our integral, which is the integral of 1 over x squared minus 4x to the 3 halves dx, we can actually rewrite this as the integral of 1 over x minus 2 squared minus 4 to the power of 3 halves dx. And now, if we do a U-substitution, so we're going to let u equal x minus 2, then du is dx. We'll end up with the integral of 1 over u squared minus 4 to the 3 halves du. And so notice that now, after we've performed the substitution, we do have a format u squared minus 4, which is this one up top here, u squared, and then minus 2 squared, right? So that is the key. The key is completing the square. Okay, so when we get our answer, we just have to remember to back substitute x equals u plus 2. Okay. So now that's kind of step 0, so maybe we call this step 0. We're now ready to get into step 1. And step 1 is going to involve our new integral, which is the integral of 1 over u squared minus 4 to the 3 halves du. So I'm going to set up my triangle. And I'm going to work with, down here I'll have this be the square root, or not, the square root of u squared minus 4. So let's put that in here. And then up here this will be 2, and this will be u. And theta will be here. Again, if you're unsure about how I did that, go back and a few steps up and check out the video on step 1. Now that I have my triangle that's going to give me the relationship between u and x, I need to, u and theta, I need to rewrite these terms. So I've got here 1 over the square root of u squared minus 4 cubed, and I have a du. Okay, so it looks like tangent of theta is equal to 2 over u squared minus 4 square root. So that means 1 over the square root of u squared minus 4 is equal to 1/2 tangent theta, which means this cubed is going to equal this cubed, which is 1/8 tangent cubed theta. Okay, so I've got that part. Now I need to figure out du, right? So I figured out that this is going to be 1/8 tangent cubed theta. Now I just need to figure out du. And the relationship between u and theta that I'm going to use to find du is going to be as simple as possible. So sine of theta is 2 over u. So that means u is 2 over sine theta, which means u is 2 cosecant theta. And from here, it's very easy for me to figure out du in terms of theta and d theta. It will be -2 cosecant theta cotangent theta d theta. Now, do you see how helpful it is to have your derivatives memorized? Because it cuts down the time that it takes to do the problems. Instead of, kind of stumbling at every single step, you're just, making your way through the new material. Okay. So now we know du, and I can actually just copy. Okay, and then I want to say here that my du is right there. Okay, so I want to combine these bits of information. Copy, paste. Okay. So I'm ready to combine. So I've got this is equal to the integral of, now I have -2 and 1/8. I can pull those together and I'll have -1/4. And on the inside, I'll have tangent cubed theta, and I'll have a cosecant theta and cotangent theta d theta. Now, right off the bat, I'm hoping things cancel out because remember, tangent and secant hang out together, right? Cosecant and cotangent hang out together. So tangent and cosecant, they really, they just, it's just kind of awkward, it's kind of awkward. So hopefully some of these quantities will cancel out. I can tell right off the bat that a cotangent is going to cancel out with one of my tangents because tangent and cotangent are reciprocals of each other. So that's helpful. So I'll have -1/4, the integral, tangent squared theta, cosecant theta, d theta. And let's see what we can do. Tangent squared is going to be sine squared theta over cosine squared theta. And cosecant theta is 1 over sine theta, d theta. Okay. All right, so this sine and one of these signs in the numerator will cancel each other out. We should end up with -1/4 the integral of sine theta over cosine squared theta d theta. Now, I'm not even going to bother to turn this into something involving, like I could say tangent, what is it? Sine over cosine would be tangent, and then 1 over cosine, tangent secant. I could do that. Tangent secant. What is tangent secant? Whose derivative is secant tan? Secant. Right, the derivative of secant is secant tan. So maybe this is, what I was going to do is I was going to do a U-substitution. Let U equal cosine of theta, and then du equals negative sine theta d theta. Right? That's what I was going to do. But another thing I can do is rewrite it as negative 1/4, the integral. See, I'm going to split up the cosine in the bottom into sine over cosine, which is going to give me tangent of theta, and 1 over cosine, which is going to give me secant of theta. And then I have my d theta, and then I just say, oh, that's the derivative of secant theta. So negative 1/4 secant theta d theta, which works. And that's actually faster than if I had done the U substitution. So that's nice. Plus a constant. So I'm done with my step 1, right? Step 1 is essentially saying that this integral that I have in terms of U is equal to this integral in terms of theta, assuming that we're following this triangle right here. So let me copy and paste the triangle. Why is the triangle important? It's important because it's kind of like the recipe or, the receipt. Sorry. It's kind of like the recipe or the receipt. Sorry. Because now, so actually I did step 1 and step 2 here, right? So step 1 would be writing this integral in terms of a trig integral, okay? And then step 2 is evaluating the trig integral. So going from here to here is step 2. And now to do step 3, where I back substitute, I'm relying on this triangle to tell me the relationship between U and theta. Okay, so what is secant of theta? I look at my triangle here, and secant of theta is going to be, secant of theta is 1 over cosine. It's the reciprocal of cosine, and cosine is adjacent over hypotenuse. So we'll have negative 1/4 hypotenuse over adjacent, right? Okay, plus C, which should be negative 1/4 hypotenuse U over adjacent, square root of U squared minus 4 plus C. Are we done? No. Because remember, U is actually a U substitution because we completed the square. And so, yeah, so here it is. We said that U, believe it or not, is actually equal to x minus 2. So we need to put that in here at the bottom here. So U is actually x minus 2. And in the bottom, what is x minus 2 squared minus 4? It's going to be exactly what we started off with. Right? So that's going to be, that was the whole point, was to rewrite that x minus 2 squared minus 4. It's going to be x squared minus 4x. So we can write this as negative 1/4 x minus 2 over the square root of x squared minus 4x plus C. And I need a brand new color to indicate that we are done with the problem.